We're to the point where we want to protect everything inside of the admin folder because we don't want just anyone to be able to create, edit, and update content in our CMS. Now this means we need a user management system, and we essentially have three options. We can use what's built into ASP.NET, we can use a third-party solution, or we can roll our own. For a variety of reasons, we are going to roll our own. It does require a little bit of extra effort on our part, but I believe that it's worth it in the end because we are in control and it's not going to change on us like some other systems. So let's start by creating the database tables that we want to use for our user management system. Well, first of all, we need a table to store the user information. And for right now, we're just going to keep things simple. We need an ID, of course, for the table. We also need the username, a password, and an email. At some point, we might want to add a bio or something like that, but we're just going to stick with the absolute basics. So first of all, we have the ID column, which is an int, and it is not going to allow nulls. Let's go ahead, right-click, and set that as primary key. And then let's also set the identity specification to yes. So we have the primary key. Next, we need the username. So let's just call it username. This is going to be in varchar, and 50 is going to be fine. That's probably more than what we would need, but that will work. This, of course, cannot be null. The same is true for the password. This is going to be a little bit longer because we need to hash our passwords. So let's do an varchar of 250. I believe that that is going to be well bigger than what we need, but I would rather have more space than too small. And then finally, the email address. So let's just call it email. Let's see if we have an email type. No, we don't. So let's make this an varchar of 50. That should be plenty, although, you know, I always am fearful of not having enough space. So let's do varchar of 75. That, of course, cannot be null either. So let's save this as users. And then we want to create another table for our roles because we are going to have a set of permissions. This will allow us to not only control who has access to our admin folder, but also who can do what. Like, for example, we can have an administrator, and anyone who is an administrator can do everything. Then we could specify an author, and an author could be able to create and edit their own posts, but they wouldn't be able to do anything to other people's posts. And then we could have an editor role, and an editor would be able to edit anybody's posts as well as delete them. I like the role-based permission scheme, so that's what we're going to do. So we need another table. Let's give it an ID. And as far as other columns, all we really need is the role name, because we are going to have another mapping table that maps the users to their roles. And so there's really nothing else that we need inside of this table. So let's just call this name. Let's make this an varchar 50. That should be plenty. And we do not want that to be null. So let's set this as a primary key, the ID that is. And we also want to set the identity specification to true. And let's just call this roles. And then finally, we need a mapping table for the users and the roles. So ID int, not null. We want user ID, which is an int and not null. And then role ID, which is an int and not null. And then, of course, we need to set up our primary key, and we need to set the ID column as the identity specification. And we can call this users roles map. And now that we have our database tables, the next thing we need to do is write the repositories for these tables. Now, I've already written the repositories, or at least most of them, because we've done this before. It's the same basic stuff. We have the get methods, get by ID, get by username. In this case, this is the user repository. We have the get all method to retrieve all of the users within the table. We have the add, which has the username, the password, and the email. Then we also have the edit and the remove, and the role repository has the same thing. We're not doing any fancy joins or anything like that because we don't want to do those joins. Whenever we want to check to see if a user is in a given role, we want to hit the database because that has the most up-to-date information. We don't want to cache that information and use what's in the cache because that could be out of date. So let's look at the user repository because this is the repository that is incomplete. You can see that the add method and the edit method have these to-do statements. We need to execute these SQL statements. The reason why I chose to do these on screen is because we have some passwords here that we need to encrypt. You never, ever, ever want to store passwords in plain text. So let's look at the add method, and we want to execute this SQL statement. We are inserting into users the username, the password, and the email. So let's call db.execute, and we will pass in the SQL statement, and then the values for the username. In this case, we have a variable called username. And then we have password. Now, we don't want to use just the password variable because that is the password that has not been encrypted. We need to encrypt it before we store it in the database. So we can do that with a class called crypto. Now, I already have a using statement here, but this resides within system.web.helpers. And this was a fairly recent addition to the .NET framework, and it's very nice because it has several methods that make it easy for hashing and verifying passwords. Now, what we want is this hash password method. Now, usually you would want to use a salt because that makes the hash a little bit better. Well, it's not a little bit, it's a lot better than just hashing a password. The salt is already taken care of with the hash password method, so we don't have to worry about the salt. All we have to do is pass in the password to hash password, and then that takes care of everything. So that it's going to hash our password with a salt, and then that will be stored in the database. And then we want to store the email as well. We kind of want to do the same thing for the edit method, where we are still executing a SQL statement, but here we want to encrypt the password that is being supplied to the method. So we pass in the SQL statement. The username is the first parameter, or parameter 0. The password is parameter 1. Email is parameter 2. And then the ID of the user is parameter 3. So we need to pass the ID there as well. And that will complete the user repository. So let's go ahead and let's close that. And the role repository is complete. We have the get methods, we have the add, the edit, and the remove. And the remove also removes the roles from the mapping table as well. Because if you remove a role, then you can't have a user mapped to that role. And the user repository does the same thing. Whenever you remove a user, it also removes the user mapping in the mapping table. So now we have everything set up for managing users. In the next lesson, we are going to create the forms, and we'll start fleshing out the code for authenticating users and verifying their permissions.